Alright, so my science project experiment was on solution density versus buoyancy. So how much the solution density plays into the role of how buoyant an object would be once it's dropped into it. And so my question, statement, or hypothesis is, what effect does the type of density of the solution have on the buoyancy of an egg? And so type of solution, density of solution, meaning in my experiment I used water, cooking oil, and hand sanitizer. 3 different types of solutions with 3 different densities, and how their effect would take place on an egg. So my outcome statement would be that the denser the solution, the more buoyant the egg will be. Since the denser it works together, the solution is, the more likely it is for the egg to sit on top of it. That was what my outcome statement is. So my content statement. What is the science concept examined in this experiment? Well, the concept to me is about the density of a solution, or its properties, which is something I just went over this week with some students. Properties of matter and how everything is matter. Well, in solution, you can define things by properties. Thinner solution, thicker solution, color, what's in it, and so on. So how does the solution's properties and density affect the buoyancy of an item, as well as its effects on gravity, meaning the denser the solution, the more it can push against gravity. Gravity does not push the object down that's inside it. So, what is the key vocabulary for this experiment? I went with buoyancy, obviously, which is the ability or tendency to float in water or air or some other fluid. The buoyant force, which is, I kind of touched on it a moment ago, which is the upward force exerted on an object wholly or partly immersed in fluid. So when you go into it, it's the buoyant force is displacement of the solution. If it's displaced more, the egg will float. If it's displaced less, it will sink to the bottom, because that's where gravity is fighting against the buoyant force. A solution is, the mixture of fluid or solutes dissolved in solid. Density, the degree of compactness of the substance, right? So we can say, this is the density of a solution where there's spaces in between. This is a very dense solution, okay? Properties, again, touched on it a moment ago, whether it's traits, whether it's qualities, okay? Displacement, the weight or the volume of fluid displaced by a floating or submerged body. And then gravity, which is the force that attracts items like the body, this chair, this screen, to the ground on physical mass, okay? So, how does the science concept apply? Well, the knowledge of gravity, or the weight of displaced fluid, is important to buoyancy, so understanding both is important to understanding buoyancy. Should the amount of solution displaced by the object placed in it be equal, it will float. Okay? So what this means is, the amount of solution that is displaced, right, if there's more solution displaced than the weight of the object, it will float. But if there's less fluid displaced than the weight of the object will sink to the bottom of the solution, because the force is not greater than gravity. So my variables, my manipulated variable, the type of solution. That's all I'm really interested in changing right now, is the type of solution, right? I'm not wanting to change the size of the egg or the weight of the egg. I want that to remain the same. And in turn, my responding variable is the buoyancy. So I'm using the manipulated variable solution to see if I can get a responding variable of the buoyancy, or how much the object will float. So my constants, the temperature of solution, I want to remain the same. The amount of solution will remain the same. I want the same opportunity or volume for density of every item. The container, because I want everything to be measured the same, will stay the same. The egg will stay the same. I don't want one egg to be this big and one egg to be this big, and then that's not going to lead to an accurate result of buoyancy. The height the egg is dropped in Sure, I could drop an egg in from this high, and it probably hit the bottom of any dense material, or of at least the three that I chose. But if I drop it directly from the water line or solution line, and I think that's a better because it's less gravity force pushing down on it. And the means of measurement, which would be centimeters using the same ruler. So my materials: water, hand sanitizer, and cooking oil are my three solutions. The container to put the solution in, the measuring tape to measure the buoyancy, tape to attach the measuring tape to the container, and then pencil and paper to take my results. So my procedures: I will clean and dry the container. I don't want any contaminants. I will attach the measuring tape to the side of the container with tape so it's fixed for all three types of solutions. I will fill the container with the solution to a preset height of 3 inches. I will wipe off the egg because I want it all to be clean, no issues. I drop the egg from the height of the solution line, right? Solution line is 3 inches. I put it right there and I let it drop. I want the egg to come to a complete rest. So that way, if it does go to the bottom, it hits the bottom. It doesn't slowly work its way down and I decide to take a random measurement somewhere in there. I want to do the measurement from the bottom of the egg, in my opinion. Because depending on how the egg lands, it can land where it's more vertical than it is horizontal on its flat side or thinner side. So I don't want that to dictate how the buoyancy is. I want where the bottom of the egg lands. Okay? Repeat steps 4 to 6 when using the same solution. So drop the egg, measure it, take it out, drop it again. And then repeat steps 1 and 3 when you're switching solutions, because again, we want to make sure everything is clean. So here's my data. In looking at this, water and cooking oil, essentially the egg was not buoyant at all, whatsoever. There was only a slight difference in the cooking oil in that it seemed to take just a hair longer for the egg to hit the bottom, but not by much. It was really sanitizer that made the difference, and this is measured in centimeters. So you can see there's an average of 3.36 centimeters was the buoyancy of the egg in the solution. And here's the median mode range. Again, easy to measure water and cooking oil because it's all zeros. When I look at sanitizer, the median was 1.65 centimeters, the mode was 3.3, and it had a range of 1.8 from its lowest buoyancy measurement to its highest. Okay? And then my conclusion, or my graph, I'm sorry. So I'm looking at the graph. It's the effects of solution on density and buoyancy of an egg. So as we can see, it's graphed out based on average measurements at a 3.36, with the sanitizer being the highest and zeros for water and solution. So in conclusion, that the denser solution, the more buoyant the egg would become. In this case, the amount of buoyant force or solution displaced was greater in the sanitizer than, or significantly greater in the sanitizer, I should add, than the water and cooking oil, because in those two it just sank to the bottom. Okay. So real-world applications. The relationship between a solution's density and the weight of an item decides whether the item floats or not. And then we get into properties of matter, different types of solutions, what are their properties, what can help you decide more likely what will float and what. Okay. Examples include ice floating in water. Everyone drinks water throughout the day, hopefully. Maybe they have some ice in it. Floating in the pool. Or ships floating at sea. The last one I felt was especially important when it comes to designing and then building the appropriate ship for what you're trying to transport. You have to know how buoyant is it going to be with the materials and what its intended cargo is. Here's my narrative, right? Started November 10th, completed November 17th. And my sources.